Mr. Shridhara CN. He is a qualified civil engineer with masters Prestressed Concrete Structures and is presently positioned as an associate director, technical and marketing at PRECA Solutions India Pvt Limited. He has an experience of more than 18 years in designs and detailing of large-scale precast structures. He is a life member of ICI and was a guest faculty at organizations like NAC, NCB, ECSI to educate the engineers in precast technology. Today, Mr. Sridhara will talk about implementation of precast technologies in construction of roads, bridges, and buildings. So, delegates, let's welcome Mr. Sridhara.
Today we'll talk on that implementation of precast technology in the construction of roads, bridges, and buildings. Say precast means what is the difference between now actually in the present situation and precast. If you compare the cast in situ construction and precast, you will see the easiness in the construction and health, so many pollutions will decrease and so many advantages you will get peoples in implementing the precast technology. For example, if they want to cast the column using cast in situ technology, they has to spend lot of materials in the shuttering and lot of trees has to be cut and used for shuttering material, and manpower energies, they has to pour concrete to the column inside, and this much energies has to be spent. If it is a precast, they will cast the column at the factory and bring to the site and they will erect using the cranes. Even if you think of casting the slabs, hundreds of laborers are required to cast the slabs in cast in situ, and so many number of wooden poles or shuttering materials are required to cast the concrete, support the slabs and all as a shutter material. If it is a precast, all these slabs will produce at the factory and they will bring and erecting using the cranes at site. Here in the cast in situ, you required hundreds of people at the site. In precast, hardly 6 to 7 people will be there, which against to hundreds of people. And again, we want to construct a wall. Think of 35 floors, block by block, and to give the form of the wall. If it is a precast, they will bring the casted walls at the factory and they will erect without any hindrance and without spending much manpower energies. Precast factory, not at site, where we can use the precast elements, seaports, bridges, residential, commercial, hospitals, schools, even metros, stadiums, office towers, and factories. All the sectors where we are constructing at present using other technology, the precast can be adopted without any hindrances. Normally, the precast vendors, they will take as turnkey services from costing to design, manufacture, delivery, and erection of the precast elements. Most of the people are not interested in the taking the overall finishes of the building, and if the tender required, then only they will think on that, taking the total project. Normally, what are the precast products available in the market? There are precast columns can be done, even pre-stress precast beams can be done, even retaining walls can be done, even slabs, hollow core slab is there, solid slab is there, that can be produced in the precast pre-stress technology. Even double T slabs can be done, staircases will be there, even boundary walls, even service ducts, even any architectural elements like curve element or any type of elements can be produced. Cladding walls, external walls, internal walls, even architectural fins, Anything can be produced in the precast. Only thing we have to make the mold and pour the concrete. And even if you want any replicas or any logos on the element can also be accommodated in the precast elements. Now some knowledge I will throw on how the precast roads can be produced. These are all precast payment design. Usually payments will be designed as a flexible payment and rigid payment. Two type of designs will be there in the road. So these are all individual slabs. They will produce in the precast prestressed slabs. You can see here prestressing strands will be there, and here also ducts will be there to connect each slabs together afterwards after erection. That can be done in the post tensioning. So you can number of slabs can be erected. Once it is erected, they will run the cables in the another direction. This side anyway, prestress strands will be there, and another longitudinal directions the cables will run and they will post tension in the pockets. And then they will grout. This is the erection, some pictures. See here they are doing pre-stress pre-stressing process. There are already pre-stress is done and locking is done. Then they will grout these areas. This is the completed road. You can see in India, you can see how much disturbance will be there in the construction of the roads for the traffic movement. If they use in the precast technology, in the night they can do kilometers of roads. Daytime the people can ready to use that roads without any hindrances. That advantages will come if they implement precast roads in India also. These are all some of the slabs they will store at site before erection. These are all erection, some methodologies. These are all jointing process actually, cross slab to slab. These are all post tensioning and final surface you can see. And now the precast technology can be used in bridges. In India itself, so many bridges already done using precast. Today also they are doing with the precast technologies. Normally the decks will, some people will go columns and all cast in situ, and decks they will do in the precast. And some people they will go with segmental decks. Even if our all Indian metro tracks are all segmental decks design. These are all precast decks, and they will put in the position. Then they will later post tension all these decks to transfer the loads and all. And some people they will do precast pre-stressed girders, and they will do slabs as a cast in situ also. That all depends on design. This technology in the bridges especially it is done so many bridges in India also. You can see anywhere, any major city if you go, you'll see the flyovers and metro that is done in precast only. And how precast buildings can be done. This is one of the hospital building. You can see this is columns, precast columns. These are all foundations cast at site using conventional method. All the connections, whatever required as per design, will be implemented in the cast in situ foundations. And once foundations are ready, the columns will come and erect. These are all you can see. This is 2-floor single column, and all these brackets and all corbels we call that is created to rest the beams in the floor, first floor and second floor level. This is the, even we can go 2-floor, 3-floor single columns, and even sometimes single floor also. It is all depends on as per design and as per the logistic availability at the site. That design department has to take a decision before finalizing their design as per the site and design requirements. These are all after column erection, the beams will come and they will erect the beams, and they will grout column and beams. And once beams are erected, the slabs will come and rest on the beams. You can see here the beams, how they are connecting to the column. There will be dowels in the corbels, and there is two holes in the beams. The beam will slide into the dowels and then they will grout together. This is one type of connection like this. So many types of connections are there. The designer has to take a decision on the connection, which connection is suitable for his design of the building. These are all already slabs are erected here. See the upper level, again beams are started erection. You can see hardly you'll see 3 to 4 people manpower at the site. That is the advantage in the precast technology. Even whatever holes you are seeing in the beam sleeves, these are all predefined MEP services sleeves. There no need to chip or drill at the site. It is all predefined. The slab which is erected, all the MEP requirement will come along with the beam. Only they can put pipe and all inside this. You can see slabs erecting on the beams and all. Even in this slab, you can see so many number of openings. These are all, suppose toilet area and all floor traps and all is required. That is all implemented in the production itself. When we erect slab, all these MEP requirements are in place. And in the normal case, they will always chip and damage the slabs. That all can be avoided in the precast because these are all predefined openings will be made at the factory itself as per the MEP consultant requirement. You can see wall erections. See this all again beams and all erected. See once the slab is erected, there is a thin layer of screed is required above the slabs to connect all the elements together. There will be reinforcement projecting from the beams and all this screed reinforcement will be connected to the beam. And once it is connected, the casting of screed concrete will happen. This normally minimum is 50 mm thickness is required. And again, the thickness is depends on span of slab and the camber what we are getting in the prestressed slabs. According to camber, the screed thickness has to be defined by the design department. This year all screeding is done. Once this screeding is done, the upper level erection, they can continue without any hindrances. You can see this is below is one column and again above is another column they erected here after screeding, and they will continue erection upper level. You can see this is also about 16-meter long beams. You can see the building, existing building is beside this. Even only 20 mm gap will be there in between the beam and the wall. Without any disturbing that existing building, the precast erection can be taken place. That is the accuracy you will get in the precast technology. Even some people have cantilevers cannot be made in precast slabs. Even that can be done in the cantilever. That proper design has to be done. We can easily make the cantilever slabs using precast prestressed slabs also. You can see all this canopy and all this are 4th floor level canopies. Without any problem, they can do easily in the precast technology. This is the finished product of the hospital. In all the precast product, they can do directly paint on the precast element. No need plastering above the precast element because all these elements are produced using MS molds, proper molds, and compact properly. No honeycombs will happen, nothing will bad quality will not come. They can directly paint and they can use for the building. This will reduce lot of maintenance in the building for the future, and it will save lot of materials at the site, wastage at the site. And also curing is not required for precast element at site because all elements are cured at the factory and they will bring to the site. This itself will save lot of water wastage at the site. And the precast technology will help lot to minimize the environmental pollutions in the construction industry and also improve the construction fraternity, hey, life also, because in Caste Institute the engineers and laborers, they knows only what time they have to go to the site, but they don't know what time they will go back to their home. There has to stay at the site if concreting is there, sacrificing their family and health and all. In the precast, everything is predefined. The schedule will be there in the before starting the project. All the laborers and all, they will stay, they work like a office at the site. They'll come in the morning, they'll go back in the evening. That is the advancement will be happen in the construction industry if they implemented the precast technology. Now in India, this is growing, this technology. Now people are adapting slowly to their project. Definitely, this is the future in the construction industry. See, these are all finished picture. Nothing is done directly. They painted on these elements. These are the advantages you will get in the using the precast. That's what I want to highlight about this technology, because they given only 8 to 10 minutes. I can cover this much uh, because our all presentations will go hours together, 1 hour, 2 hour. That is the thing actually. Then we can go elaborate talk. Uh, Thank you.